Hello, and welcome to AP Computer Science A, Unit 2 by Bizinstitution. So the first thing we'll be looking at today is classes. So in the last video we talked about how char is actually a primitive value while string is not. String in Java is actually a reference type. So to get into more understanding the difference between the two, a primitive value is the most basic type in Java, and it has no associated methods. Classes made by programmers that use primitive types are reference types. So reference types are basically programmers use primitive types and make classes with them to make reference types. And these classes can be initiated, and they also have associated methods, and primitive types, meanwhile, don't have associated methods. So, the next thing we'll be looking at is objects. So what are objects? Variables that are user-defined are objects, but those variables that are user-defined, if they're reference types, they're objects. So not necessarily just reference types, but anything that is a class that is stored in a variable is an object. For example, string is a reference type. It is a class. But when you store a string in a variable, let's say you store a string called programming is fun into the variable random text. Random text would be an object. It is an instance of a class. An object is an instance of a class. So objects have both state and behavior. State is basically the data of the object, and behavior is the actions. For example, on our right we have a rectangle. Let's say a state is data, right? So what would be some data about the rectangle? Maybe the length, the width. To be honest, those are the only two things you can really think about a rectangle. But yeah, so the length and the width would be the state of the rectangle. And then the behavior are the actions, so things you could do with this data. So calculating the area, calculating the perimeter would be a behavior, because it is an action done by using the data. An action is performed, which is calculating the area, which is a behavior. So objects are created from classes. They are instances of classes. And think of a class as a template. Like I said, we have a string. A string is a template, and you store it in an object. For example, a rectangle class. So on our left here, think about this as a rectangle class. It has a bunch of stuff inside it, and it's basically a template. A rectangle object is an instance of a class. So a rectangle class could have it has a template. It has a template for the shape name, it has a template for the width, and it has the template for the height. And a rectangle object would be an example of that template. So let's say you had a building. Let's say a building was a class. The Empire State Building would be an object, because a building is technically template. The building doesn't mean anything if it's not referring to a specific building. But Empire State Building refers to a specific building. So think of the Empire State Building as an object, and then a building as a class. Same in this case. A rectangle is a class, and rectangle 7, which I just randomly decided to create, is an object. It is an instance of the rectangle class. So rectangle 7 has a width of 4 and a height of 15, and rectangle 7 is the name of the rectangle object. And you can see on the right is that this is the object. This doesn't mean this is the only possible rectangle. That's just the rectangle that I created. But rectangle class itself is a template to create any rectangle. But rectangle 7 is an object, which is an instance of the class. The next thing we will be looking at is creating objects and overloading constructors. So the first thing we will be looking at is how to create a class. So if you remember from the last video, we talked about the Java skeleton. However, that is for the my program main method. But that is not the only file you can create. You can create many classes. Usually programmers tend to create these classes in separate files. So you would not write this code in the myprogram.java file. You would write it in a different file called rectangle. Usually the name of the class and the name of the file are the same. So public class rectangle would be in the file rectangle.java. So this is how you started the class skeleton. You just say public, which is the keyword, and then you say class, which is another keyword, and the name of the class. In this case, we're dealing with a rectangle, so I just said public class rectangle. And then a class usually always has some instance variables. What this means is that you declare these variables, but they're not initiated. The difference is that when declaring these variables means that you create them, but initiating means that you assign them a value. These variables are just there, private int width. I didn't say a equals something. I didn't say private int width equals blah blah blah. It's just private int width. So we declared them, as in we created them, but we didn't assign them a value yet. So usually instance variables are almost always private, because if because people shouldn't be able to modify them directly in the main method. You can create methods in the class to modify them, but not the variables themselves should usually be private, unless a very specific reason needs to be made them public. So this is a constructor. A constructor is basically what it is. It constructs an object. You have a template, which is a class, but you were trying to create an object. To create an object, you need the constructor basically creates the object. Without the constructor, there is a no call constructor, but we'll look at that later. But basically, to create an object or an instance of the class, we have to have a constructor in the class. So the syntax for the constructor is pretty similar. Instead of saying public class rectangle, you just say public rectangle without the keyword class, and say these two are parameters. So these two are parameters for the instance variables on top of here. So basically, you public rectangle int the width and int the height, and this is something the user would input. These parameters are what the user would input. So let's say they inputted the 4 for the width and 5 for the height. Then it would be width equals 4 and height equals 5, because these parameters are what's stored into these variables, and the variables actually get initiated inside the constructor, but they get declared before the constructor. This is because an object has many purposes. You could use many methods with it, and you have to have variables and these methods use the variables in the class, and then these variables are assigned values with the help of the constructor. So for example, all of this code is in the main method, by the way. So this is how you create an object or an instance of the rectangle class. It is pretty similar to how we did user input for like scanner input equals new scanner system.in. It's similar, but we're not using the scanner class. We're using the rectangle class. So we just say rectangle, which is the name of the class, and then rectangle7, which is the variable name. That's just the name I chose. It can be any name that you wish to do, but remember, variable names need to be meaningful and not just some random names. So I just said name of the class, the name of the variables equals the new keyword, and then the name of the class again, rectangle, comma, and these are our parameters we input. So 4 goes into here, and 15 goes into here. If you look here, rectangle, parentheses, 2 parameters. Rectangle, parentheses, 2 parameters. That's how Java recognizes this is a constructor. So when you say new rectangle 4, 15 in parentheses, it creates an object. So we have a constructor for 2 parameters. And then when it goes into here, we say rectangle 4, the first parameter is the width. So the 4 is the width and 15 is the height. And we know it's that because we say width is the first parameter, which is the variable, the width, and height is the second parameter, the variable, the height. And you won't be able to do the second and third option because for the second option, you can see that 4 is enclosed in quotation marks. That means it's a string. Now, as you can see here, the first parameter is an int. So the type in the parameter and the type that you use in the main method have to match. If it mismatches, there will be an error. Same for the number of parameters. There's 2 parameters for the constructor, but but I only inputted 1 into the main method. This wouldn't work because there's nothing to go into the second parameter, and the code would throw an error. However, to fix this, we can do something called overloading. Overloading is when the code has multiple constructors with the same name but different parameters. Basically, in the previous example, we talked about how if you only had 1 parameter, it wouldn't work because the constructor has 2 parameters. However, simply, you can create 2 constructors, or even more, 3 constructors, or however many as you like. So the first constructor is pretty similar to the one in the previous slide. The second constructor, however, only has one parameter, and then both width equals the width and height equals the width. This intuitively doesn't make sense, but when you think about it, if it's a square, all sides are equal. So technically a square is a rectangle, but not every rectangle is a square. So if I want to make a square object in the rectangle class, it's still a rectangle object, but I want it to be a square. I could say a rectangle 8 equals new rectangle 34, 34, and that would still be the same thing. But simply, you can just create another constructor and say 34, which means that it only takes in 1 parameter. So what Java does is it looks for this thing, rectangle 34, and it goes to the first constructor, and it sees it doesn't work because in the main method it is 34. It does. By the way, I keep saying the main method, but you will later learn that you can declare these objects and create these objects in any class. It doesn't have to be in the main method, but usually most of the time you make them in the main method. But it can be in any file, any class, as long as the constructor and the class is public. So as I was saying, it looks for the constructor, and it sees that the first constructor has two parameters. These 2 do not match at all. So then it goes to the second constructor, and now these match. So it creates an object using the second constructor and whatever code is inside the constructor, and implements that code. It doesn't care about Java doesn't care about this constructor and this constructor. And you can also have a constructor with no parameters. In this case, you can let's just say I just want to create a rectangle, and then there's usually not a reason why you would have hard-coded values, but let's say I just wanted to create a rectangle, but I don't know what width and what height. You can just put predefined width and height. So when there's no parameters I put in the main method, or anywhere else where I create the object, it can just have default values, which is 15 width and height 27. Usually although you can do this, I don't see a point in doing this, because usually you wouldn't. If you wanted to create a random rectangle, for example, you would generate a random number, which we'll be learning how to do very soon. But yeah, you can always overload constructors. It's like, think about this as redundancy. You can create redundancy so that even if you have the different number of parameters as intended, the code will still run because you have a constructor for that. So the next thing we'll be looking at is methods. More specifically, the first type of method we will be looking at is void methods. So what is a method? A Java method is made up of several statements that work together to complete an action. That's like the book, that's like the official book definition. But basically, like I said, if I go back to the class, these variables width and height are like the state, and the methods are like the behavior. Remember state and behavior? So these variables would be the state of the class, and the methods would be the behavior. So they're basically a bunch of code that work together to complete an action. It completes an action. A void method, meanwhile, is a method that does not return any value. So that is indicated because we say public void method name. That is the key, signature. We say public, which is a keyword, and void, which indicates there is no return type. And then the name of the method, which is print area, and that's just the name I chose. Well, there are also methods with return type, but we will be looking at in very soon in the next couple slides. So you may have remembered about user input, and we've already used methods in user input. Those are methods that were already in the scanner library, but like if you remember, we did input.nextLine, input.nextDouble, and input.nextInt. Those are all methods that we used. Those are all methods. However, now we'll be looking at how we create methods. Just like variables though, methods should also be written in lower camel case, which is just good naming practice. So this is a method. Let's say you wanted to, so the action for rectangle is finding out the area. So let's say you wanted to print the area to the console. So you could just say public void print area in brackets. That's how you say a method. You say public, but instead of class, if you said class, it would be a class, and if you didn't put anything, it would be constructor. But the keyword void indicates that it's a method, and it's also a method that does not have any return type. So public void print area brackets, and then we can just say int. We can just make a temporary variable called int area equals width times height. You may be wondering, where did we get the width and height variables from? Keep in mind that methods are written in classes. So you would write a method right after this constructor. So right after you do the variables, constructors, you would write a method down here. So these methods use can access the entirety of the class. So these width and height variables are actually the width and height variables from the class. Those are the instance variables, and it can use them. So what values do the width and height have? Usually when you use methods, they're corresponding to the object. So whatever whatever the object has, whatever state the object has. So if the object has a width of 4, let's say rectangle 7 for example. If I go back to rectangle 7, I had my example was width of 4 and height of 15. I create rectangle 7, and I make it so that the constructor creates it with a width of 4 and a height of 15. It uses that because I would say rectangle 7.print area to run that method. So it uses those values into this method. So this just is a very, very simple method. You can have much more complicated methods. But what I did here is I said int area equals width times height, and then I said system.output.println area, and which is what prints it to a console. And this is what I did. I ran this in the main method. By the way, this code would be in the class, this code would be in the main method, or you could use it in any other method, but for now let's just stick to the main method. And I said rectangle 7.print area. Rectangle 7 is an object, and I said rectangle 7 dot method name. So object dot method name runs the method for this object. So rectangle 7.print area will return 4 times 15, which is, sorry, my math is bad. 4 times 15, which is 60. So rectangle 7.print area, sorry, not return, my bad. But void methods do not return anything. Rectangle 7.print area would result in the 60 being printed into the console because we created a temporary variable called area, which says that area is width times height, and we print area to the console. So rectangle 7.print area would print 60 to the console. So more on void methods. Void methods, just like constructors, can also have parameters. So let's say you wanted to create a method where you don't print anything, you don't return anything, but you wanted to change some of the state in the value. Like I said, this is why we keep the instance variables themselves private, but we can create public methods that can alter the instance variables. So in this case, I created a public void change height method, int new height, and then I'd said height equals new height. So basically I can just say that I can run in the main method, I can say rectangle 7 dot change height, and in parentheses I would say 6. Now rectangle 7 has a width of 4 and a height of 6 because I changed it using this method. And methods in this case can also be overloaded. So just like constructors, you can also overload methods and say public void change height int new height comma int new width, and just change height and width with if the user decides to input 2 parameters. Sorry, this is a mistake. I put a dash, but that is supposed to be an equal sign. So just ignore that. That is supposed to be an equal sign. Although this is kind of a weird example because if it's called change height and it changes height and width, maybe change dimensions was a better name, and you would, as I said, you should have good naming convention, and this is a very bad example of naming convention. And usually there's many other cases where you would use method overloading, and this is one case, but sometimes if you want to change the height and the width, most likely you will just have one method for the height and one method for the width. But yeah, my entire point here is that methods can be overloaded just like constructors in case more than one parameter or less than whatever number of parameters is the expected amount needs to be implemented. The next thing we'll be looking at is non-void methods. Non-void methods are basically methods with a return type. So the difference between the signature for a non-void method and a void method is, as we said public void no return method, but this time we say public int yes return method. So no return method and yes return method are obviously names. You can call them anything else. You can in fact call them the same thing. But a void indicates that there's no return type. But this keyword indicates what return type. So if you said public string method name, it will return a string. Public int in this case would return an int. And one thing to keep in mind is that the value that the method returns must be the same as the method type here, or else there will be an error. So in this case, on the left we said public void print area, and I said int area equals width times height system.output.println area. We already saw this method in the last slide. Oh well, a couple slides ago, but yeah. But what if I wanted to get the area and store it in a variable? I can just say public int get area and said same thing, int area is width times height, and instead of printing the area, we can return the area. What that does is, on the left side, if you were to do this, int area equals rectangle 7.print area, this wouldn't work because it is a void method and it has no return type. So when this method doesn't return anything and you're trying to store it in a variable, that would throw an error and this literally would not work. However, on the right side, sorry, that's a typo. It's supposed to be get area, not get area. Anyway, on the right side, we can say rectangle 7.get area, and get area returns area. So you can store it in a variable. So in this case, think about returning as like this. When you call the method and it returns something, the method itself becomes the value it returns. So when I say rectangle 7.get area, this entire line becomes the value it returns. So for rectangle 7, I think I had 4 and 15. Let's just say 4 and 15. Rectangle 7.get area returns 60 because 4 times 15 is 60. So rectangle 7.get area, this entire line essentially for Java is 60. So essentially it would be int the area equals 60 because that's the value that this line is returning. So you can also put these into print statements. On the left side you can't do that because you can't, the rectangle 7.print area doesn't return anything, so it's a void method. Don't mistake this print statement with this print statement because this is just executes it. So it will print this, but it won't print it again because it's it cannot print it because it's a void method, so it doesn't return anything. But on the right side, it returns something, so it returns 60, and essentially 60 is inside this print statement, and it will print 60. And just to get rid of any confusion, methods with return type are not just integers. You can do public boolean method name, public string method name, public double method name, and literally any type you can think of. So basically methods with return type return stuff. If it's a void method, it doesn't return anything. And there's several implications. There's several applications of methods, but this is just one simple. As you progress through the course, it gets a lot more complicated. So the next thing we'll be looking at is strings. This may sound odd because we already know what strings are, but there's still a lot more to learn about strings. So strings is a reference type. Remember, it is not a primitive value. So technically, a string is a class. So we can write string in two ways. So we can just say string random text equals programming is fun. However, we can write it as if we're creating an object. So we can say string random text equals new string parentheses programming is fun. This wouldn't work with int because int is a primitive type. But since string is a class and you can create an object, this will work. You can say string random text equals new string parentheses programming is fun. You would never do this because there's not really a point. But this is just to learn so that you would know that string is not a primitive value. Think about it as this way. Char is a primitive value and string is a class. String uses those chars to create a string, which is an object. Since string is a class and it is an object and it is not a primitive value, it also has associated methods built into Java. So like I said, print area, get area, that's a method. String also has many methods. But one thing to keep in mind is that strings are immutable. That means they cannot change. So when methods are used on strings, they basically create new strings. So let's say I said string random text equals programming is fun, and then I said random text equals random text dot whatever method, and then it would change, right? But it would not change the existing string. It would just create a new string and store it into the original variable random text. So the next thing we'll be looking at is string concatenation. String concatenation is basically how you join two strings. Two strings can be added together into one string. You can also do concatenation with primitive value. You don't have to do with just strings. So basically, let's say we had a string variable called random text equals programming is fun, and then we had a string variable called more text equals and Java is fun, and then I created a variable called final text equals random text plus more text, and then I printed final text, and then I said programming is fun, and as you can see, it combines them two. But you may notice it looks a little funky because Java does not add a space for you. You have to add it yourself. So if I were to do this wouldn't, well, it works, but it doesn't make sense because there's no space here and there's no space here. So programming is fun, no space, and Java is fun. So I said string final text equals random text plus new text, more text. So this text plus this text basically just joins them together. And Java is not like a human, so it doesn't have like the common sense to add a space, if you see what I'm saying. However, in the second example, you can see I added a space after the exclamation mark, and you can see now if you look in the console, it makes a lot more sense for a human to read it. And like I said, you don't have to create a variable, create another variable, add them together, store it in another variable. You can just do all of this into one line and create this into a print statement. So you can just say system.output print line. Like I said, you can use primitive values. It doesn't have to be a string. 5 plus space, because Java doesn't have the space, is my favorite number. So I said 5 plus space is my favorite number. And then that's 5 is my favorite number because, Java doesn't add any space. So I added the space. And you can do concatenations with primitive values. So I did 5 plus string, which results in this being outputted into the console. And I did all of this into just this is print statement. Last thing is, just like addition, subtract, addition, we can also use the plus equals shortcut for string values as well. So you can do concatenation with plus equals. So you can do like random text plus equals another more text, or random text plus equals is my favorite number. So here are some useful string methods. So before we look at the methods, please pay attention to the top of the screen. let's just say, for the sake of understanding the methods, we already have a predefined variable called random text, which has the value of hello. String random text equals hello. So, sorry. Sorry. So, we have a method called randomText.concat_cool. What the concat method does is that it returns the string or parameters added to the end of the string. So you don't have to do string concatenation like this. You can simply say random text, which is this, dot concat cool. So in this case, it will return hello cool, and there would be no space because Java doesn't add your spaces. Another useful method is random text.replace l comma p. What this does is it returns a string where all instances of the first parameter is replaced with replaced by the second parameter. So in this case, all instances of L would be replaced with P. So hello would return, when you run this method, it would return hepo. And then lastly, we have random text.toUpperCase. This returns a string where everything is capitalized. So in this case, it's pretty self-explanatory. It will return hello with all caps. Before we look at even more methods and about more string methods, we have to learn about string indexes. So how many letters are there in hello? There's 5. This is the first letter, second letter, third letter, fourth letter, fifth letter. However, strings are, okay, let me just read this first. Strings are sequences of characters, and each character has an index. So an index is the corresponding number to the letter. So H is the first letter, which is 1, E is the second letter, which is 2. However, in Java, you don't start 1, 2, 3, 4, 5. It goes 0, 1, 2, 3, 4, 5. So in Java, an index starts at 0. So this is technically the third letter, but for Java, it is the second, not really the second letter, it's still the third letter, but it has an index of 2. So the fourth letter has an index of 3. So what I would, if I were to say, what is, let's say there's a really long paragraph, and I would say, what is the fifth index? You would not actually look for the fifth letter, you would look for the fourth letter because it starts at 0. So H has an index of 0, L has an index of 2, the second L has an index of 3, O has an index of 4, and E has an index of 1. Some more string methods. There's a lot of string methods and it can be very useful, so please stick with me. So the first method we'll be looking at is random text.char@. So what it does, it returns the character at the index. Okay, before we look at this, I just want to let you know that there's random text is already predefined and it has the value hello. So random text.char@ returns the character at the index value inside the parameters. So if I say random text.char@4, it will return the index value of 4. So the index value of 4 is 0. Oh, so because 0, 1, 2, 3, 4. So random text.char@4 would return O because O is at the 4th index. Random text.length is the most self-explanatory one. It returns the length of the string. So in this case, it will return 5 because hello has 5 letters. In this case, it's not like index where it starts at 0. It is just human. It has a length of 5, so it will return 5. Random text.substring returns the substring between the first parameter and the second parameter, where the first parameter is inclusive while the second one is exclusive. So in this case, it will return L. So because random text.substring, the first index is 0, 1, 1 is inclusive, so 1, 2, 3, 4, ELLO. But 4 is exclusive, so it would only return 1 between 1 through 4, where 1 is inclusive and 4 is exclusive, so it would be 1, 2, 3. So 0, 1, 2, 3. It returns ELL. And then the random text.index of I finds the first instance of the value in the parameter, and it returns -1 if not found. But in this case, it will return 2 because, sorry, this is not an I, this is an L, my bad. They both look the same, my bad. But yeah, random text.index of L would return 2 because the first instance of L is at the index of 2, 0, 1, 2. Sorry. So random text dot equals hello returns a boolean value to see if the string inside the parameter matches the string. So in this case it will return true because random text is hello, hello dot equals hello, they're the exact same, capitalization matters, they're the exact same, and so it will return the boolean value of true. My bad for putting them into quotation marks. True is not supposed to be into quotation marks, that would be a string. It is a boolean value, so it would just return true without the quotation marks. And the last thing we'll be looking at is random text.compare to. This basically compares random text to the text in a string in alphabetical order. So it returns an integer, the string minus the one in the parameters, and it is based on alphabetical order. This is actually a bit complicated. I recommend looking up the compare to method and understand how it works. And I recommend looking up the ASCII table because it uses the ASCII table to see which one is alphabetical and how one number is bigger, I guess, than the other. Sorry, one letter is bigger, I guess, than the other letter. The next thing we'll be looking at is wrapper classes. So we know primitive values, char and double boolean. However, they have corresponding wrapper classes. So think about the wrapper class as a string. It is an object. They have corresponding objects. So char is a primitive value, character is a class, int is a primitive value, integer is a class, double, capital D with a double is a class, boolean, capital boolean is a class. So what's the point of all these wrapper classes? Literally, what's the point? Remember, I said primitive values do not have associated methods. But classes, objects, reference types, all of them have associated methods. Since they are classes, they have special methods that are useful to a programmer. For example, the integer has a method called integer.minValue and integer.maximumValue, which return the lowest and highest possible integer that Java can handle. You can Google them, it's all online. I'm pretty sure integer.minValue is like -2 billion or -2 trillion, some number, and integer.maxValue is like +2 trillion or 2 billion, some number around there. And which means that Java cannot actually go past, like, it cannot handle 10 trillion. It has a cap on how big of a number the code can handle, which is integer.minValue and integer.maxValue. Here's the cool thing. You can put this into a print statement and find it out yourself without Googling it. So you can just say system.output.println integer.minValue, and that would print what the minimum value that Java can handle and the maximum value that Java can handle. So you can also initialize these things, wrapper classes, as objects. Just like string, you can say integer num equals new integer 15. However, if you said int num equals new int 15, this would not work because int is a primitive type. Integer is not a primitive type, it is a wrapper class. Int is a primitive type. So be careful there. If you said int num equals new int, it wouldn't work. But if you said integer num equals new int, it will work. Most of the time you just say integer equals this or int equals this, but this is just to let you know. There are also several methods. Just min value and max value is just two examples. Double, boolean, all of those have several inbuilt methods. So one example is another integer method which can convert a wrapper class into a primitive value, and this is the syntax for it, integer.intValue. Okay, the last thing will be, this is supposed to be a 7, I accidentally put a 3 here, but yeah, the last thing we'll be looking at is the math class. So before we talk about the math class, we need to know about static methods. Static methods are really amazing because we can call methods without creating objects. So on the right, I have two static methods: public static void static method 1, public static int static method 2. Static methods can be void or int, it doesn't matter. I mean void, or it can have something with a return type, it really doesn't matter. And it can have anything, it's just like a regular method. However, going back to the rectangle example, you can just say rectangle dot static method 2. You don't have to create an object saying rectangle 7 equals new rectangle, and then say rectangle 7 dot static method 2, which corresponds to the object. You can see why this is useful, because in the next slides we'll be talking about the math class, and instead of creating an object saying, oh, math variable equals new math, and then saying variable dot exponent method. That doesn't make sense. You can just say math.exponent or math.square root. I'll tell you then more about these methods in the next second. But the entire purpose of static methods is that you don't need to create an object. You can just use the class name. So, well, I spelled rectangle wrong there. Sorry, I made a lot of mistakes this time. My apologies. But yeah, you can just use the class name and not the not the object name for these methods. So you can just say rectangle.static method 2 or whatever the class name you're using is. That's why if you remember, you can actually say like if a string or anything has static methods, you can use string dot something. But as far as I know, as far as you need to know for this course, you don't need to know any static methods for strings. However, the math class has many static methods that are very useful. So the first method is math.abs_num. It's pretty simple. It returns the absolute value of num, which is num is just, it can be a number, it can be a variable, it can be anything as long as it's a double or an int. Math.pow base common exponent returns the value of base raised to the power of exponent. So if I said math.pow 4, 5, it would return 4 to the power of 5. Math.sqrt would just return the positive square root of the num. So math.sqrt25 would return 5. And math.random returns a random double between 0.0 and 1.0. So you may be thinking, what is the point of math.random if you can only generate a value between 0.0 and 1.0? However, we can use a little bit of coding to make it generate a number from whatever we want. So the number we want is math.random, and this is basically a template, int random variable, and you cast it into int math.random times range plus 1 plus start. So let's say we want to generate a random number between 5 and 10. So we start at 5, so 5 is the start, so plus 5, this corresponds to this, and then, sorry, there's supposed to be a parentheses here, because you're casting it, and it shouldn't be added at the end, it should be before it's casted. Actually, it wouldn't matter because it's just a plus 5, so with parentheses or without parentheses wouldn't matter, so that's why I think I didn't put it, but it's a good practice to put it. But yeah, let's say you want to generate a random number between 5 to 10. 5 is the start, so you would say this is the start, and then the range between 5 and 10 is 5 because 10 minus 5 is 5. However, it's range plus 1, so math.random times 6, range plus 1, plus 5, and cast it into an integer, would return a random number from 5 to 10. Thank you, and that's it.